Welcome, everyone. Thank you for joining us for today's live webinar on solving hybrid cloud network issues with full stack observability. My name is Kashif, and I will be your moderator today. The speaker for today's webinar is Vince Hill, who is a Senior Technical Marketing Manager at Packet Networks. The pattern for today's webinar will be a presentation followed by a quick demo on Microsoft Azure platform and a Q&A session at the end. So please enter your questions and we will address them towards the end of the webinar. So without further ado, Vince, handing over to you.
Okay, all right. Welcome, everybody. Let me do this. I need to bring my slides up, I think, to full. Okay, that should be in full mode now. All right, so yeah, welcome, everybody, wherever you're joining from. My name's Vince Hill. I'm not going to spend time introducing myself other than say that I've been involved in specifically to cloud and network visibility and observability for about the last 4 years. You can go ahead and go to my LinkedIn if you want to see more details about myself. This session is going to be focused on network troubleshooting with observability. And we're going to focus, as I said, on both cloud. We do support data center and also hypervisor virtualization environments too. And so let's jump straight in. So I'm going to focus initially on architecture and deployment patterns, and then I'll drop into the observability use cases, and then I'll go through some production incidences that we've experienced over the past 6 months or so. And so that I think that would probably take about 30 minutes. I've got about 28 slides just to, provide the foundational pieces. So then when we jump to the demo, you can see exactly what we're doing and how we accelerate incident response and how you can get to network issues very, very quickly. So that's the plan. So let me jump straight in. So I think, in terms of the technology, media, and the space that we live in, I think a lot of the news centers around security and breaches and improving some of the numbers there. But I like to follow some of the reports. Before COVID, the mean time to detect and recover repair were actually trending a little down, but those have now been trending back up. So that's been a little worrying and concerning that the reports are now definitely trending the wrong way, including the cost of breaches and other, the risk of getting impacted by ransomware, is going up, and the cost of dealing with the security issues. This session here is going to be really actually going to be more focused around the challenge of incident response, dealing with user experience and service outages. That number there of 5,600 per minute of downtime being the average cost is a little dated, but still really relevant. I think the last time I kind of searched around it, that number would look like it was up 30%. You can see there also that the outages, internet outages, are also trending up as well. So that's something to be mindful of and concerning. So the challenge in the cloud that we're going to be talking about here is really about network packet capture or acquisition, both packet capture and storage, historical, going back in time to see what happened days ago or weeks ago, PCAP retrieval, and providing analytics around that. And so, of course, in the cloud, that's a little bit more challenging based on the fact that when you're in the data center, we typically use taps and packet brokers, and of course now, how do you deal with that in the cloud? Other considerations in the hybrid environment, it typically comes down to the tool location. So depending on what your tool strategy is, whether you're evaluating new tools for the cloud into VPCs and VNets, or whether you're backhauling back to the data center with over ExpressRoute and and direct connect sessions and connections. But these architectures are still evolving, and what we mean by that is that new services are still being added all the time. So every quarter, new services come out from the cloud providers. I think last week Azure just put out its pricing and SKUs for gateway load balancing, and the quarter before AWS launched their mirroring to gateway load balancer services. So that's what we mean by evolving. The options and for you to use in the environments are still being added to and still evolving there. Other operational considerations, it's not just the cost of running instances and virtual machines in the environments, it's also the cost of and the impact of the network services in the environments, especially with agents. So as you add more services into the environment, so you start to get production resource contention with the virtual CPU, memory, I/O, and so forth, right? And we cover that when we talk about agents. So yeah, let's move on. So just if we look at the objectives, our customers are typically one of these categories. It's either user experience and reducing service outages. It is top of mind. The other one there is strengthening the cybersecurity, so replication and forwarding full packet services out to those tools. And then accelerating incident response. So we've had a lot of customers that have gone through the process of dealing with network outages. They may be dealing with the service provider and going back and forth, trying to figure out which side of the network ownership that falls on. So it may come back as you may get asked to provide the PCAP file, right? So show me a PCAP, send me the PCAP, and this process doesn't just take days. Often it can take longer. In days, you can go into weeks of troubleshooting and frustration and service degradation. So the way we look at it, or broken it down here, is into layers, right? Of what can you do instrumentation-wise in these environments. So if I start at the top there, in the application layer, so there's application agents, virtual taps, you'll hear sensors, containers that you can provide into your production environments. This tends to create or certainly exist application resource contention, meaning that if a virtual machine has a gig of traffic coming in and a gig going out, and you want to fully replicate all that traffic, that virtual machine or incident needs to support 4 gigs of traffic. So certainly manageable. You can manage that, especially if for lower amounts of traffic. But it's something that needs to be considered and dealt with in the environment. The other thing that the applications require typically is the application owner approval. So they may have not have designed their platform to have these extra services in the environment when the operational team come in to bring it up to compliance or to the standards of that organization. So sometimes that can cause conflict. And also the agents and containers also require things like raw I/O net admin privileges. So that can also create some challenges getting those services enabled. The next layer down there is the network access layer provided by network virtual appliances. This is where the virtual instances and virtual machines, things like packet broker services, can be put into the service chain. These are agentless. These are always on and transparent to the users or the application owner. So they don't even know that the traffic is being replicated and stored away, or there's no visibility from the users or the application owners. And so we're going to be focused in this area as I go through to the solution and what we can do at CPACIN. The bottom layer there is the cloud native services being provided by AWS and Azure. These are the ones that are being added to all the time. So you can see there that AWS, the VPC mirroring has been around for quite some time now. And Gateway Load Balancer is being added to, and in the last couple of quarters, the mirroring to Gateway Load Balancer as well. Google's GCP or Google Cloud, I think it's called now, but there's packet mirroring that's been around for a while. Azure announced back in December, and I think it's just gone live last week, is their gateway load balancer offering. And then just a note on the mirroring. Mirroring has some limitations around how many times you can replicate off of that instance interface and things like that. So things to be aware of as we go through. The layer here that I'm going to next is the hypervisor layer. Everything that can be done in the application layer stays the same, but of course the service provider goes away here. But then you're talking about back into network and virtual appliances, all the goodness that brings, and then port mirroring and other services there. So just a little bit around the requirements in these environments, typically from the network services. So you can see down here, you may be dealing with branch to data center connectivity. You may be dealing with cloud and data center. So from the network services point of view, typically we get a lot of requests always on and lossless for the security folks at least. How do we do replication and forwarding in the environments? Provide that PCAP storage so you can actually go back in time and see what's been going on. And of course, enabling this across both multi-cloud, the hypervisor and hybrid cloud environments as something that needs to be addressed as well. So just onto the architecture. So here at cPacket, our solution, we've been in the data center for a decade or more. So this is rack-mounted, one rack unit or two rack unit type devices. We provide a C view for the packet brokering and forwarding and replication services. C-Store provides capture and analytics for us, and then C-Clear is a device that we use for observability, visualizations, and dashboarding. And what we do in the data center virtualization is what we can provide in the cloud with network virtual appliances, where the C view is put it behind an Azure load balancer for the backend pool, so we are able to then provide the forwarding and replication services out to both the tools and both for the packet capture and analytics. So we provide a C-Store V for that, and then a C-Clear as well. So you can see that as examples here. So if we break this down a little bit more as I kind of peel back the onion, if we start with the network packet services with the C view for aggregation, replication, and forwarding, we then forward stream out to the C-Store V for packet capture analytics. This is where we provide simultaneous feeds, indexing and search capability. So you can pull back those PCAP files for historic forensics and troubleshooting. And that also then gets picked up by the C-Clear to provide the analytics dashboards. And this is what I'm going to do during the demo, is show you some of the screens and the dashboards and how you can troubleshoot your environments. So this is kind of a simple kind of diagram here, but you may also, you're more likely going to have multiple points in the network that you're going to want to monitor. And so, you would have multiple points with the C view presence and then multiple C-Stores in the environment as well, feeding up to a single pane of glass with the C-Clear V there. So just a little bit on enabling end-to-end monitoring. So I guess this is a very simplistic view of just a client server or server-to-server type TCP connection. But once we drop into the environment with the C view, we can actually pick up key performance indicators between the client and the server. So you can see here we're showing just response time, round trip time, processing time, and so forth, right? So we can pick up quite a lot of the key performance indicators in establishing that call and conversation. If there's a network device, we can sit either side of that, and depending on which side that we view, you may monitor both sides, but you'll see retransmissions perhaps, and then on one side you'll see duplicates. On the other side of this, you'll see gaps, right? So it depends. And again, this is still a very oversimplistic view of what's going on in your network. But this is when we start talking about the what, when, where, and why. So we could definitely see the what and the when with timestamping and things. A little bit more tricky to see the where, where it's going on in the network. And of course, the why. So this would be, again, still simplified view of it. But of course, you've got multi-hops in your, this one's showing a cloud data center. It could be a branch data center, which would have multiple, we call them middle boxes here, but they're really just network devices. You may have access and visibility to a lot of it, but not all of it sometimes. So you may be, it's this conversation between A and B is actually, very complex and busy sometimes. So, so you may choose to opt to monitor multiple points in this network, and of course, the more points you add into the network for monitoring, increases your percentage of the where, right, where it's going on in your network. But in this kind of simplistic view, that would all the monitoring would get sent up to the ClearV, and then we would show these dashboards, and then you'd be able to troubleshoot where in the network or what's going on, the what, where, and when. So yeah, so you get maybe the why would be the application. Maybe it's an application issue, or a one of these devices is dropping the connection. So that's anyway, that's just a kind of oversimplified way of just showing that. Let me just do a time check. Okay. So let's move on to deployment patterns for the cloud. We tend to talk about this in terms of traffic flow. What traffic you're trying to get to, right? Is it VPC to VPC? Is it VNet to VNet in Azure? Are you trying to get to VM traffic? Are you trying to get in and out traffic, so north to south? So we've so this has been documented for us in certainly the first basic 6 use cases. We've kind of documented in the blueprint for cloud. So you can go and pick up and read that, and we go through some details around how to do that. But you can see here that for when you're in the service chain, it's lossless. It's a little bit more complex when you talk about mirroring, depending on how much traffic is being handled by the mirroring service, and whether you're looking for lossless as the service or not, or whether just you're not too worried about it, but you want most of the traffic, so the best effort. So you can read here, and there's a link here that the AWS have published. This is their statement on mirrored traffic, that they prioritize the production. So mirrored traffic can get dropped when congestion, and certainly we found burst traffic has been dropped in that example. So what do these look like? You can see here the description with UDRs, user defined routes. So what does it look like? So here's just what that would look like for us. So the traffic between this use case 1, which is VNet to VNet into subnet traffic. We use UDRs, so to send traffic via the Azure Network Load Balancer, and then this backend pool handles the replication and forwarding services, and that can go out to security tools, and for us, we send it out to the C-store. So all the traffic going between these 2 VNets will be captured and forwarded out. We've also found that we can actually get to the VM traffic, VM to VM as well, again using the UDR and the appliance pool. So again, that's the second use case here. And then north to south, maybe firewall in the process. So getting your traffic going in and out of the network as opposed to across the network. So that's the use case 3 there. Let's switch over to AWS. AWS has a couple of services, and so mirrored sessions. So this is when the interface is mirrored. It's been out for quite some time. So you can then forward that to the network load balancer, and that can do, you're basically offloading any replication that's required here over to the backend pool, and the same again. So that's mirrored sessions. Another one would be using the gateway load balancer services. So this is using Geneve every time you want to add a VPC into networking, you would add a endpoint, a gateway load balancer endpoint into the environment, and tunnel that to the gateway load balancer, and then we would replicate the traffic that way. And I think the last one here we're going to show is the north to south. So that's 6, but it's not limited to 6. There's more use cases, but that just gives you a flavor of how to deploy in these environments. And you can go to that the blueprint doc that we've. I'll give you a link at the end to. So let's. So there's others. There's just the next iteration of use cases will include Azure's gateway load balancer, and then we're going to add in the mirroring gateway load balancer service from AWS as well. So there's other use cases that we'll be adding to here in the next months or weeks. So let me move on to the use cases. So I'm going to just do some before I get to the demo. I'm just going to go through some use cases, and I'm just going to use some screenshot type so that you can see when we connect into our CClear, what are we showing, what can we do. So when you log into CClear and go to the dashboards, you can see here we've got a number of out-box type of dashboards that you can click on. So you may go to latency and see what's going on in that segment. For latency, you might click on the IP address, and this will give you a much greater detailed view of what's going on over time. So you get the what and the when. There's a box here for downloading the PCAP file, so you can go straight to this box here. We've got Berkeley packet filtering in there. If you know your IP address, you can put that in, and you can filter out that and download that PCAP file very quickly. So that would just be a quick example on latency. Another one would be retransmissions. So this view here for health, each one of these rows here is a different segment in the network. So I'm not sure if you're on a laptop, you might struggle, but I'll just talk through it. So that top row would be, it says here DMZ. The one underneath that is a lab, which is actually the QA and development environment. And here we've got R&D under here. So you can see R&D is pretty clear, but unusually for a 30-minute period, we've got millions of retransmissions. So just this view, you can say, okay, I've got problems in this segment of the network. I'd click on that red box. It would give me the top offenders in that for the retransmissions, and you click on the top one maybe, and then you get a breakdown and detailed view of that very quickly just by clicking 2 or 3 times into the environment. If I get a phone call that has both either the time of an event or if the platform team say they're seeing issues on a specific server with an IP address, we can go straight to CClear and do capture. This capture window here allows me to see, I can combine the view across multiple C stores, or I can actually just choose one C store. I can click on time, so I can go back in date. So I could go to last week. I could put a date and time in here. I can say, how much time I want to see in the next 30 seconds, 2 minutes, 5 minutes, whatever that is, and just click download. And I'll show this in the demo, by the way. So that would give me the PCAP file for that period of time on that date and time. So that would be very quick to do. In the data center, I can actually monitor specific ports, both for burst traffic and average. You can see here, this one's showing. You probably can't read this on your screens, but I'll just talk through it again. So that's blown up a bit here. So in this case, we're showing both the throughput and the baseline. So after so many days, we have an algorithm. We actually show the predicted traffic. This example here is showing 4 days. My guess is this is Saturday, Sunday, Monday, Tuesday, Wednesday. You can see we're predicting Thursday, Friday here. And you can see that this example has been trending just above the baseline here. So they've had some extra traffic there. So that's baselining, and you can, capacity planning may be interested in this as well. Just one other to just mention is volumetric attacks. We can see TCP SYN flooding, HTTP and application flooding. I'll demo that in a second. The one that's not on there is we also have customers that want to monitor certificate versions and things like that. So we can actually show that as well through custom dashboarding. But you go ahead and click on the health, click into these boxes, and oops, there you go. I'll slow down a little bit. But you can see here the bursting and the flooding failures, or you can go to the application window and see what ports their flooding's on and things like that. So you get very quick access to that as well. So just a couple of quick production incidents before I go into the demo, and I'm about 30 minutes, which is good. So just a quick couple of here. So this would be, and I'm going to demo this as well. So you'll see two virtual machines in 2 different subnets here with different IP addresses, traffic going via the Azure load balancer. And again, we'll show you the screenshots. So in this case, you've got a production. Oops, let me go back. Sorry, I'll slow down. So you can see at this top row is production. The next one is default and monitoring. And then here is your key performance indicators from response time in the network. Round trip latency, 0 wins, which is dealing with nodes that are being resource constrained. Retransmissions in errors and new sessions. So you would click on new sessions and you would get both your IP address, you get the time. So this one's actually showing the last 30 minutes. So if I was to go ahead and look at 5 minutes, I'd actually miss this actual flooding event. And you see the port number. So very easily, I can just go ahead and put that time into the packet capture download. And this is the download. So this example, you can see that this IP address, the 314, is flooding 304 and on port 880. So very quickly we can find that. That was simulated, but this was actually an event that was handled. This top network monitor is actually says there AWS. Again, you probably can't read that, but it says AWS for this one. This one was a lab. And these other network monitors are looking fairly clear. So you go ahead and click on the retransmission box. The screenshots were taken during the event, so they didn't come out very clear. But here you can the top offending IP address was the 1051.10.207. So we're able to click into that, and basically once we got the IP address and the time, we were able to just download the result. And this is what we found. We were seeing out of order packets on the IP address. So this was the time to pick up the phone and call the engineering team and let them know that they've got a problem with one of their servers. It ended up that it was a vSphere virtual machine that had hung, so it wasn't responding to user input, so in keyboard, but the IP stack was still responding, and so they were happy to hear, because it was actually a QA system that was the issue on that occasion. So very, very quick and very easy. I mean, I've gone through these examples very quickly, but that's really how quick it is to actually get the information that we're looking for and try to solve issues out on your network. So just a couple of resources before I switch to a demo. Both these incidences and more have been written up. One that's more focused around cloud, and we also have isolating network problems. We go through the KPIs and things that we work with, and so there's 2 links down here. But if you don't remember those, it's fine. You just go to cpacket.com resources, and you'll find all these papers and application notes. There's the blueprint. So I think this was. So you just go to cpacket.com resources, and you can find those papers and find more info. So that's the content. How am I doing for time? I think I'm good for time. I'm just going to pause for a second. Yeah, so we're at 1:30. So my environment for Azure is I have production VNet and a default VNet. I have my instrumentation and my monitoring in the monitoring here VNet as well. Oops, let me switch over. And so I'm going to be sending traffic between the Ubuntu, the 10.3.1.4. So remember that IP address, and then the 10.3.0.4 is the device under test. So you can see here, this is a very simplest, a very small environment, but you might have hundreds of nodes or servers or VMs in these environments. But I'm just going to show you 2 here. So let me. Okay. So, and I'm going to be accessing the C-Clear here, which is at 13.06 for the dashboards. So let me switch over. Let me just make sure that I'm still live. Can Cash or Ed, can you just let me know that I'm still live?
Once you're good to go.
Okay, thank you. Good to know. Okay, so let me minimize this. So and let me start from the C-Clear. No, it's not logged out. Okay, so let me just go back to here. So just on the left windows here, I have access here to my Ubuntu instance and my window. Let me first, I guess, go to the Azure environment. So hopefully you can see that. Hopefully it's big enough. But this is my Azure setup. You can see I have I have a Windows. I'm actually going to use the Ubuntu and the device under test, which is a Windows. Traffic doesn't show on the Azure dashboard, but the traffic is going via this load balancer. And behind the load balancer, I have a couple of CViews. Our default actually recommended is 3, to have 3 on there. And then these are replicating out traffics to the C store. My jump server is just access RDP into the environment and so forth, right? So that's a jump server. And then I have my C store and my C-Clear device in the environment. So that's that. So if let me start by just logging into the C-Clear. So under C-Clear, I would go to, this is a small environment, so I just have a single C store. You can see that the traffic rate receiving on that is low right now, but it's changing, which is good. The monitors that I've set up are for the monitoring subnet, the default, the VNet default, and the production there. So that's what these are, and these are the subnets that we're monitoring. And then I can just go to, without going through all these admin capabilities and so forth, I'll just jump straight to dashboards. So when I jump into the dashboards, I get some default dashboards that I can click on. If I go to health overview, this will give me all the traffic and the state in there. If I click on that, it will actually now break that out into those monitors. So hopefully you can see this, but if you can't, I'll talk through it. So up here is the monitoring network. Underneath that, I have the VNet default and the VNet production. So you can see here response time. My latency is very good right now. You can see, and the other KPIs here, we're 0 wins, retransmissions, SYN errors, and new sessions. So if I had 20 monitoring points in my network, I'd have a long list of these down here. So this would all be populated. So in this case, I just want to see my VNet and my VNet production. So I would just say, okay, just give me that give me these two. So let me see if I can create some traffic, and let's see if we can move the round trip time. So let me go ahead and start. I'm just going to use a little script here for downloading. You can see here that from here, I can actually see the last 30 minutes. I can see the last hour. If I go back further, I probably did a test this morning. Yep, so I did first thing. So if I go back further in time, I can see I created things here. So let's go back to 5 minutes, and then I'll do a refresh of the screen every 5 seconds. So we've already gone from 1 point something milliseconds. So we've added 30 milliseconds or 35 milliseconds into the latency already. I don't know if I can do more on that. Let's do another one. Oops, let's go to this one, see if I can push it a little bit higher. So this is just an SSH into the Ubuntu. So that's the 3.1.4. So if I click into this now, it'll tell me, oh, so my latency is on my 3.1.4, which is my Ubuntu, because I'm driving the Ubuntu instance is doing all this right now. So I click on the IP address, and if I look over time, let me just give the last 15 minutes. The last 15 minutes, I really wasn't doing anything, and you can see here that the latency was what's that say? That says 690 microseconds. But if I go to the last 5 minutes, you can see the ramp there over the last 5 minutes, and you can see that that's going on, right? So very quickly, and I can actually just look at the latency in there. So that's that one. Let me back out of those. Let me just do a time check. So I've got about 5-10 minutes left. So we're up to 48 in right here. So remember, I'm updating this. Remember, it's an average over 5 minutes. So let me go ahead and try something else. Let me do a flood on that. Let's do a SYN. Let's do an ACK. So I'm going to flood from the 3.1.4 to the 3.0.4, right? So I'm now going to flood the device under test. So let me just go back and show that again. So I'm now going to flood from this so I'm going to flood this device under test. Okay, let's go ahead and do that. Remember, this is without any agent, so no agents running on either of these servers or VMs. And so we're just going to do a quick flood. All right, there we go. So let me stop that now. So very quickly, we can see here new sessions are being created. So if I click on there, you can see down the IP address that's being flooded, which is a 304, and you can see the timing come through. So I can see this, the what, where, when, very quickly. Just a couple of clicks, just 1-2 clicks away, right? So very quickly. Let me do this. Let me go back to CClear. Right? So let me go to capture. I don't want to overflood the nodes because the Windows, if you overflood, I could crash my Windows node there. So let me go ahead and do that again. This would be by capture. If I did, now in this case, I know that it's being flooded, but I can, put the time and date in. I'm just going to do now. I'm going to limit the size of the file to 10 meg. I only need like 5 seconds here because I'm flooding. And I don't need to use the Berkeley packet filter. I just go, okay, just give me the quick one. So I don't need to put any IP addresses in here and just download that file. So it's going to give me 10 meg there. Let me stop that before I crash my Windows box. And I click in there. And you can see here that I'm being flooded from the 314 over to the 304, and you see those are ACK acknowledgement packets there. So very quickly able to grab that. I'll do one more before I stop. So let's go back to here. Okay, I'll do one more at the application layer. So let's do an HTTP flood. Let me flood HTTP traffic. It should be here somewhere. There we go. So let's pick a port number. Let's do random 888. There we go. So I'm going to now flood. I want to see that stop for it. It's just, I wonder if that caught it. Let me go back to CClear. Packet capture, and I'm going to do the same thing again. And so now you can see the flooding on port 888 there, 8888. So you can see that very quickly. We can pick up the PCAP file. Obviously, on a larger network, this would be more of an impressive. I'm dealing here with just demoing a smaller network, but you can see and get the idea of how quickly it is to pick up the information. Let me just go back to this has now changed. So if I was just looking for the problem, I could see that now I'm being flooded. You can see the amount of flooding that's happened in the last 5 minutes on 10.3.0 here. And you can see down to what IP address, and now you can see the actual port number as well. And then you can click for more details of when and where it's happening. So that's a very quick demo. I think that's the content for the day. I'll take any questions from, any questions coming in, Cash?
Yes, Vince, there are a few questions here. Can you hear me?
I can hear you, yeah.
Yeah, so the first question from the audience is, what is the supported performance in various deployment environments?
So I think by that, let me go back to my slides here. So I think we're talking about how much performance we can support in the backend pool. Is that the question?
I believe so, yeah. Mm-hmm.
Yeah. So yeah, great question. So one of the limitations. So the way that we do that today. So we recommend a minimum size for Azure. So in Azure, it's a standard. The CVV is a standard for D4 version 5, I think. And so that will support, each one supports 10 gig. So this overall is 30 gig supporting, right? You can support 30 gig of traffic here. In AWS, their M5 extra large, I think is the, from memory, I think that's like 4 virtual CPUs, 16 gig of memory, and then storage on those instances. So those are the sizes here, and then depending on how much that we need to do the sizing here at the C-store as well. So about 30 gig. Of course, it's going to depend on the load balancer performance. So I think AWS has a limitation of 30 gig on its load balancer unless you move the needle. We can increase these sizes to increase the supported amount, but it's going to vary depending on the cloud provider and the supported networking from that. So you don't have to use the a 5M an M5 extra large. You can increase it to increase the size here. The preferred way is actually to add another CView in, so it'd be another CView, so you can actually just scale this out. So
got it.
Hopefully that answers the question.
Yeah, hopefully it does for Aldane.
So it's 30 gig and as a minimum, and then whatever beyond that, depending on the size of the backend port and how you want to, the kind of traffic that you're talking about.
Got it.
Yep.
Next question, Vince, is how do you size virtual machines?
Yeah, so we actually in that blueprint document, we have the sizing of these, which I just kind of alluded to, whether they're, M5s or standard D4s or D8s or whatever they are. So that's documented. And again, we just document the minimum. So we give you minimum sizing. So we really start at 30 gig and go up from there.
Got it. Sure. Next question is, how do you support seamless scaling?
Right, yeah. So again, that's this backend pool. You can just add more CViews into this pool, and that will scale. So again, if you've upped the limits from your service provider on your load balancer, then you can just scale these out.
Got it. And I think there's one more question here, Vince. So do you support HA architectures?
Yeah, so the H8 would be in this backend pool again. So we would, if you wanted to support 20 gigs of traffic, you'd have HA here because you got three of them. If you wanted to do 30 gig with HA, you would have to add another CView into that to have a single failure on the CViews, right? So that would be HA.
Got it. So I think, Vince, this is it from the audience. Anything else from your side?
No, just thank the folks for joining today, and reach out to us. You can do a request for demo if you want to look at this in more detail, or consider other use cases. As I said, we've documented a few, but not all. There's a lot of use cases. We'll be adding to the use cases just based on the added services from AWS, Azure, and of course Google. And so we'll be adding to the documentation. Go to our website. You can do request for demo, and you can go to our resources if you want to read up and spend more time looking at the details of what we've shown today. So that's it.
Perfect. Thank you, Vince, for sharing your expert insights and walking us through the C-Clear demo on Azure platform. And for the audience, thanks so much for attending today's webinar. We should be back soon with our next webinar, live webinar in August. Thank you again and have a great day.
Thanks.